In the previous class we found out the design strength in shear, and this is the value. Next we need to find out the design strength in bearing. And the nominal strength is given by V suffix NPB. It is 2.5 times KB dt into FU. Now KB is calculated as least of these values. First is E upon 3 D0 E is the edge distance. It's given by 30 as seen in the diagram. The next is P upon 3D0 minus 0.25. The pitch is given to us as 60. The hole diameter is 22. And here we get a value of 0.6591. The next FUB upon FU 410. This is 0.9756 and D is 1. So the value of KB has to be the minimum out of these three options. So the minimum here is 0.455 and it has to be KB will be 0.4545. Substituting all these values in the nominal strength formula, we get 2.5 into 0.4545. D is 20, thickness of the plate is 20, FU is 410. This is in newtons per. This value for V and PB is 186345 Newton per bolt. Now that was a nominal strength. To find the design strength, we have to divide V and PB by the partial safety factor, and when we do that, we get a value of 149076 Newton. The design strength of the joint will be 6 times the value of design strength because there are 6 bolts. So the design strength of the joint in bearing is 894.456 kilonewton. Design strength of bolts in joint is 271.586 kilonewton. This value is less than the design strength of the plates. Therefore, the strength of the joint is minimum between the strength of the bolts and the strength of the joint. So the strength of the joint will be 271.586. When we calculate the strength of a whole system of plates and bolts put together, we have to consider the least among them. So that is why we say that the strength of the joint is 271.586 kilonewtons, even though we get a value of 673 kilonewtons as the strength of the plates. We are asked to find out the efficiency of the joint. The area of the solid plate is the width multiplied by the thickness, which is 3600 mm square. Design strength of the plate is given by so this is 250 upon 1.1 into 3600, which is 8181.8 newtons, which is equal to 818.182 kilonewton. This is the design strength of the plate. The efficiency of the joint is given by the strength of the joint divided by the strength of the plate multiplied by 100. So the strength of the joint we know we have calculated as 271.586 kilonewtons. Strength of the plate is 818.182, and this gives us an efficiency of 33.19%. So this is your final answer. The efficiency of the joint is 33.19%. Thank you.